Good morning, everybody, or actually afternoon, whenever you guys are actually watching this. We are going to be going over our notes for graphing inverse functions and relations today. So this is your set of guided notes that you should be following along with. So our first thing we're going to be discussing is what is a relation. So this is going to be a set of ordered pairs. And for example, that's going to look like our 1, 2. Remember that you have your x, y, and then we have our 3, 4, and 5, 6. So this is our relation is a set of ordered pairs. The inverse of that relation is actually a set of ordered pairs still, but they are obtained by exchanging your x and y's. Exchanging your x and y of each of those ordered pairs from the previous example. So for example, we have our 1, 2. So we're going to switch our y and our x, and then now this is our new x, this is our new y. Same with here, just switch them 4, 3, and just switch these 6, 5. So for example, if we wanted to find the inverse of A, this is our A set of ordered pairs, or our relation here, we are going to just flop the inverse. So you always want to say inverse of A so we know what we're talking about. This is just A, that's the set of A. The little squiggly brackets represent your set, and we're just going to go through and actually switch the x's and y's. And this is our new inverse of A. For the next portion, so how are the domain and range of the inverse functions related? So when we actually discuss, so our domain is going to be all of the x values. So if we have our domain is, so from our original problem we had this is a different problem. So we have right here from this example, 1, 2, and 3. Those are our domain because it's all of our x values, and then all of our range values are the y's. So we have, from this example, 3, 4, and 5. So when we have, when we're going to be discussing the inverse of the function domain, so they are going to go, so our inverse of our domain here is actually going to be 3, 4, and 5. Remember, we just switched our x and y values, so 3, 4, and 5 are now my domain, and then my range is going to be 1, 2, and 3. So even your domains and ranges actually flop your x's and y's as well. So the domain of a function is actually equal to the range of the inverse. And then same for our range of our function, that's actually going to be equal to the domain of our inverse. Okay, so for each of those, I want you to go ahead and do this example, and then we can discuss in class on how they are actually, how the graphs of the inverse functions are actually related. So you're just going to find the domain and range of these values, the inverse of B. So we already have our, make sure it's the inverse, you guys, and not just the domain, because remember this was our regular domain for our set of A, and then we did our inverse. So you're just finding the inverse, domain, and range. And again, I want you to notice how the graphs or the points of the inverse functions are related. So go ahead and state that, and we'll go over that in class. For our example in our notes, for graphing these actually now, we are going to have our triangle ABC has these vertices. So these are all points. So we're going to go ahead and actually plot these points. So 5, 2, that's going to be my point A. 9, 5, that's going to be my point B. And then 10, 3 is my point C. There's my triangle. I'm going to go ahead and draw my triangle here. So that was just point A, B, and C. So now I'm going to graph the actual triangle's inverse. So the inverse of my triangles, remember that we just flop your points, your x's and your y's. So now I have 2, 5. This is going to represent my A value, my A point, my A vertice. Then I have 5, 9. And then I have my 3, 10. So now I'm going to plot these new points here. And when I actually get those new values, we should see the inverse. So 2, 5. That's my new A value. Then I have my 5, 9. That's my B value. And then my 3, 10. And then this is my new C value. So this is my inverse, and I forgot to show you guys that when we represent the inverse, we actually have these little tick marks. This actually means the inverse of that function. So I'm going to put little tick marks on all of these so I know that it's the actual inverse. And that's how we decipher which one was the original image and which one was the actual inverse. So now we can see that it was actually reflected. We drew a little line right here. Going through that, we'd actually see that it would actually be a mirrored image if we were to fold our paper on that. So now for this section, I want you guys to practice these. I'm going to go over one of them with you, but you're going to graph the inverse of the relation below. You're going to put your answers on that same exact graph, just like we did on that last example. So for example, if I just say like these are my A points, and then we have our inverse of A, then I'm just going to write down the points that I actually see here. So this one point is -2, 4. The next point is -1, 1. We have 0, 0. Our next point is 1, 1. And then our other one is 2, 4. I'm now going to take the inverse of those points by flopping them. So 4, -2. 1, -1, 0, 0 is going to stay the same. 1, 1 is going to stay the same because they're both the same numbers, and then 4, 2. Now I'm going to plot these new points. So 4, -2. And I know there's not graphs on here, you guys, so try and do your best to graphing these. Then we have our 1, -1, 0, 0, 1, 1, and then 4, 2. And then we see that our inverse of our function actually flipped over to the side. And that's our exact points on those. So again, it actually was reflected if we go through our y equals x. So the points that are actually on this line, that 0, 0, and the 1, 1, are going to stay on that line because it was actually on the line to begin with. Let me just focus that for you. So these 2 points were on our inverse line here, and of our line of reflection. So then the other points would be flipping. So again, if I were to fold my paper, then this little symbol would actually go directly onto there. And again, if they're on the line, they're going to remain on the line. So I'd like you guys to go ahead, write down your original points, write down your inverse points for the next 3 graphs, and actually graph the inverse of each of these functions. And then our last part of our notes, so how can you actually tell if the inverse of a function will also be a function based on its actual graph? So this we are going to use the horizontal line test. So we're going to make this nice and big. Use the horizontal line test. Okay, so what that means is if I go through and I draw a horizontal line, let's get a different color here, horizontal horizon, remember you're going through the horizon, and the inverse will not be a function because a horizontal line touches in more than one place. So it cannot touch your graph in more than one place in order to be an inverse. Okay? If we were to do our horizontal line test on this other graph, just try and draw a horizontal line. So again, it touches your graph in two places here, so it will not be a function. And then it only touches the graph in one place there, so the inverse will be a function. Because a horizontal line will never touch the graph in more than one spot. So when we see that, more than one spot. So again, we just want to make sure that it is touching the graph in one spot. The inverse will actually be a function. So you can see on our graph, one spot, function, two spots, no function. And that is our set of notes. So go ahead and do those problems. We'll go over them in class. See you guys then.